Hello guys, let's continue what we've started building our end language. So guys, in today's video I will talk about an important concept. So until now we've accomplished something good, a simple calculator. Our language is capable to make operations like plus, division, multiplication, subtraction, and so on. So this is our code. For example, our code is 2 plus 4 and semicolon. The bytecode is up constant 2 and up constant 4, and we do an addition and we halt the machine. So the VM, it has a state, its stack is 2 and 4, but until now we can't do something like this. True code, the example of code is true equal false. So the VM, it should return false because true doesn't equal false. So the bytecode of that is of true, of false, and we ask for equal and we halt the machine. So the VM stack should be something like this, true and false, and we do the operation equal. So for now our values on stack is just numbers, it's just doubles. Our VM doesn't support on the stack values like booleans, like null values, and so on. So for that we should implement new data structure, new data types like booleans, number, and null. Our old value, it store only values as double. The double is represented in memory on 8 bytes. So what we want something like that. The new value should be something like that. The first four bytes for data type, is it a null or a boolean or a number? And we have some 4 bytes for padding. Let's skip that right now, and we have 8 bytes to store to store numbers for doubles, and also to store booleans. We will use just 1 bit to store boolean. If it is 1, it's true. If it is not, it's false. If it is 0, it's false. And also we store null value in this 8 byte. We simply, it will be 000 for all 8 bytes. So why this 4 bytes for padding? It is not a waste of memory? This is a question. So no, the answer is no, it's not a waste of memory. This is useful for performance. C language, it has these 4 bytes because our CPU, remember our CPU, it read the whole memory as 8 byte. We called it word. So at a clock rise our CPU can read 8 byte. If we have 32-bit or 64-bit architecture. So why is this padding? Because let's assume that we don't have this padding. So we'll have 4 bytes and 8 bytes. So let's assume that we can read a number. Let's take for example 10, and data type is number. So I need to read the number. So the CPU, what will does, it will read this 4 bytes, this 8 bytes without padding, this 8 bytes, 4 bytes from here and 4 bytes from here, but we didn't read the whole number. We read just the first 4 bytes of it. So what will does the CPU, for the first cycle it will read 4 bytes and 4 bytes, and for the second cycle it will read the next 4 bytes. So the CPU needs 2 cycles to read our number. To solve that issue, C add 4 bytes for padding just to read our payload in 1 cycle, not 2 cycles. So let's jump right to the code, and we will update our value that support only doubles, and it will support other data types like booleans, number, and nil. So let's jump to the code. Let's list our directory. So we will update our value.h. We will remove that and I will add an enum so this enum, it will represent value type, and we'll do val number. The value type is a type number, or value is boolean, or is it nil, or the type nil, val nil. So now let's create the structure value, struct, and we will keep track of what's the type is stored, and we have union. We will use union, and we name it as, and it will store double called number, or boolean called boolean. Why we didn't store null? Because nil is simply bunch of zeros. It can represent it as a double. So the next thing I want is we will define some useful macros. Like I want to ask if it is the current value in our stack, is it a number or a boolean or nil. To do that we will simply define this macro. It accepts value, and then we use that value to check if that value its type is a number, val number. Let's do another one for checking if it is a boolean. You get the idea. Value type equal val 1. So also we will check if it is a nil value, type equal val nil. Another useful macros is to read the payload of the value. I want somehow, if I want to read number, it should return to me number. If I want to read boolean, it should return to me boolean. So to do so, we will need something like define as number, and we take the number, and also we do something like as read number, and also for boolean I will read the value of the boolean. Also for nil it's like number, as number. So let's go to, I need some macros that could define values. To do so, we need to declare these macros. Define number val. It will create a number value based on some values. To do so, we need to cast that, and I will pass the type number, and also for union I will do number, and I will assign it the value. So okay, that's it. So for I need some way to get a value type. I'll do the same thing as number. So val bool, and for Boolean it's the value best to that. And for nil val, it doesn't accept nothing. I will pass to the number 0 val nil, and number I will pass it 0. Okay, so let's add the common library to use the Boolean. Include common.h. Okay. Okay, that's good. So for now, let's update the print value that accepts the value as a parameter, and it prints the value. In the old version, it prints only double, so now we will update that to support Boolean and number and nil. So let's do that. Let's go to value. Let's see, in print value. I will remove that, or I will use it. Switch. I will take the type of that value type, and if it is a val number, I would printf the double. To do so, I will use our read macro as number, and I pass it as value. So I will add a break in case val bool. I would printf. I will check its Boolean. I will do, is it bool or no? I will read the value of Boolean as bool, and I'll do bool, and I will check if it is true. I will print true. If it's not, I will print false. Okay, so we have the last one. If case val nil, I will just printf nil. Okay, so let's remove that. So let's save that. So now let's add some support to operations like true and false and nil. To do so, also I will need to modify the VM to support the new values. So vim, see, I will update that, because remember, I pop the value from stack, but I couldn't do a operator B directly. I should read this value and check if they are numbers or not. So I will do if it is not number, and I'll pass it A, or is not a number for B. So I will print an error. For now I will just do that, standard error. I will say operands must be numbers, and I will return interpret runtime error. So if it is not, if it is numbers, I just will push a operator B. Let's do this backslashes. Okay, so good. Okay, that will be fine. Okay, so let's come back and rebuild our project and to see if we can do the calculation like 2 plus 3 and so on. So let's rebuild that. Okay, it says operator. Okay, invalid operands to the code. Okay. VM.c. I can't do value operand b because it doesn't represent directly double. It's a structure, so I need to read the value. So we will use the macro as number, and I will do operator also. I will read the number of value b, and then I will create another val number that get all the results. So let's do something like that, double and results, and I will just cut that. So then I will pass that here as number, remove this extra parentheses. Okay, then I will push the result as number. Remember that number val macros, it will return value based on the value passed as a parameter. It will return the structure, but its type is number and the value is the result. Okay, let's add these backslashes. Set a semicolon here and backslash, and we are fine for now. Okay, so let's rebuild our project. Cool. Okay, it says expected. Don't worry about this, it's just warnings. We'll be worried about this. So let's come back to our VM. Okay, I will do a backslash here. So before rebuilding our project, we need to update our compiler.c in number function, so that, because make constant it read value, but we update our value to be a structure that supports 3 data type. So we need to turn that number into a number val structure and pass it to the make constant. And let's compile our project. Let's clean that all and make all. So let's clear that, and 2 plus 2, as you see, it's 4. So we need a way to to print true and use operand true, false, and nil. And to be fast, we need to add 3 more operations to our check.h. So let's add up true, up false, up nil, and let's go to debug these. We'll add case up true and we'll return simple instruction up true offset. Also for up false, excuse me, we will return simple instruction up false offset. Also for case nil, we will return simple instruction up nil. So let's come back to our VM to support these instructions. We will add this instruction right here, case up true. We will push to our stack a Boolean value. So to do that, we will use bool val and pass true, and we break that. For also for false, push for val false, and we will break that also, and we will do case up nil, and we will push a nil val and we break that. So not yet our compiler doesn't read a string of character like true and do operation equals and something like that. To test that, we will only hard code our bytecode right after these. Before halting our machine, I will emit byte up true and emit byte up false, emit byte up nil. Don't worry, after this video we will handle that dynamically, and in other session we will read some things like true or false or whatever, true equal false or not true. The purpose of this video is just to give you a baseline for our values that support 3 data type, and for simplicity I just hardcode this bytecode here to see the result. In other session we will handle that properly. So let's make all projects and clear that, and let's test that. I will pass nothing just to see. Okay, I have up true or false. Okay, up true, it adds true and nil. So the problem is on value.c, because I didn't do a break here. So let's add that, also a break here. So let's rebuild project, and okay, as you see, we hardcode the bytecode up true, up false, and nil, and return. So as you see, up true, it loads true to the stack, up false, it loads false, and up nil, it upload nil to the stack. So see you guys in other sessions to handle more expressions like greater or equal, or less or equal, or greater or less, and equal and not equal, and some unary operators like not and minus. So see you guys in another section.